Let's do some more practice, especially the last, let's call this part 2. This will be the 3-step ones and as far as your first quiz will go. So, more practice. Okay, so a question like, if you have 30 grams of nitrogen and excess hydrogen, how many grams of NH3 would you produce? Here's your equation. Nitrogen gas plus hydrogen gas goes to ammonia. Given to you with a balanced equation, right? If we don't put anything in there, we know that that's really a 1. So we start with what you're given, always. They gave us 30 grams of nitrogen gas, so we put that there. We know then that grams of nitrogen gas must cancel. The only way we can really turn grams into is moles. So moles go up on top. If we change grams to moles, the of what must stay the same. So it goes from grams of nitrogen to moles of nitrogen. These numbers is your molar mass, grams per mole. So that's what the mass of N2 weighs per every 1 mole you have. So nitrogen's mass is 14.01 on the periodic table. We double it because there's 2 of them. Now we're in moles of nitrogen. Question is, are we done? Well, they want to know how many grams of NH3. This is not grams of NH3, so we must keep going. Moles of N2 is going to come down here. And now we have to get from one thing to the other. We're currently in N2. We have to get over to NH3. The only time you can go from one thing to another is using a mole ratio, moles to moles. So moles of N2 will be on the bottom, moles of NH3 on top. Our numbers come from our balanced equation, the 2 NH3 and our 1 N2. Since we didn't change moles, that's when we can change the of what. Okay, so now we're in moles of NH3, but they want grams of NH3. So we're closer. We have the of what. We just need to go one more step and cancel moles of NH3 and turn into grams of NH3. Again, we do this by the molar mass, grams per mole. For 1 nitrogen and 3 hydrogens off the periodic table, we get 17.03. And we get our final answer of 36.47 by taking 30 divided by 28.02 times 2 because it's on top, times 17.03 because it's also on top. You can ignore the 1s because multiplying or dividing by 1 does nothing numerically, and you get that final answer. Hopefully that makes sense. If it doesn't, let me know. Alright, let's try one more. It's going to be a little bit different. If we use the same equation, and we have 16 grams of hydrogen and excess nitrogen again. Oh, no, sorry, I flipped them this time. This time I have excess nitrogen. We're asking for how many liters of N2. So this is the volume. How much space does this N2 take up? Now note, you'll need to know this fact. You might want to write it down. So 1 mole of any gas at standard temperature and pressure, we'll get to that later. So 1 mole of gas equals 22.4 liters of volume. So we'll need that partway through this problem. So again, we start with what we're given, 16 grams of hydrogen gas. We need to cancel grams of H2, so that'll go down here. We can only turn grams into moles, so moles of H2 goes on top. 2.014, I went out a few more decimals than usual, but that's okay. To moles of H2 on top. Great, there's one step done, but we need liters of N2. We're not there yet. So we have to cancel moles of H2. To get to our new thing, we have to get moles of something else. Moles of N2 in this case on top, so it's a mole ratio. In our mole ratio, our numbers come from the balanced chemical equation. 1 mole of N2 for every 3 moles of H2. And now we're in moles of N2. We have to cancel moles of N2 and get to liters of N2, which is where this equality comes in. We know that for every mole of N2, it equals 22.4 liters of N2, and we get a final answer of 59.32 liters of N2 by doing our math of 16 divided by 2.04 grams, ignore the times, it's a 1, divide by 3, times by 22.4 liters, gets you a final answer of that. Hopefully it makes sense. If not, send questions.